Okay, next presentation we have Martin Pina. He will talk you about distributed storage using MikroTik ROS storage package. And here we are. Good luck.
Hello. So, let's start. Hello, I'm Martin Pina. I'm a MikroTik trainer, which unfortunately or fortunately doesn't play not any important role here. So let's get to the topic. What is ROS storage? And why should we even think of using it? So it's one of the extra packages which were added to routers in version 7. And so you have to install it extra. And it's for improving disk manageability in routers itself, because routers was criticized for not having the ability to let's say manage disk in the way we are used in servers. And to say some official words, it should add additional enterprise data center functionality. So what it is? You can use RAID, in fact some JBOD, which is not RAID itself. You can use RAID from 1 to 6, plus some embedded RAIDs. And you can use some block devices over network, which is iSCSI, and here, and NVMe over TCP. If we skip one line. And to the line we skipped, it has the ability to serve as a file server to provide file system over network, which we can use. And in fact, in routers you can do it in two possible ways. One is Samba and one is NFS. Which is set to work only with version 7. But Samba was moved to the main package since version 7.14, which is, I don't know, 1 week old. So it's quite news that this service has been completely removed from the ROS storage, is now in the main package. And RAM disk is also in brackets because generally you can have at disk of the time TMPFS without ROS storage. Or at least the command line offers you to set this type. Okay, so let's look at the history and some technical details. It was added in version 7.8. Do you remember when version 7.8 was released? It's approximately a year ago, almost exactly. So it's quite new, and there are only 4 supported architectures. One of them is ARM, ARM64, 886, and Tile. Architectures like multi-core MIPS is not supported, unfortunately, or MIPS big NDN. So you have to have one of those 4 to be able to find the package in the extra packages, and then you can install it the standard way you do. You can, of course, find a help page here on the MikroTik website. There is a web page dedicated to this package. Unfortunately, it's quite outdated. There are missing descriptions, so it's still, I would say, work in progress. Basically, one small remark from me: I do not know about the way how to use this, let's say, advanced disk management for system disk. It's only for additional disk that you add to the system. Okay, so why should we even use it? You can use RAID for mirroring. It may be good for Dude if you are afraid that the database will be lost due to failed drive because it's only on one drive. You can use it, but what are the buts? It's a problem that if you want to use it inside router OS, you want to use it using router OS or MikroTik hardware. And it's quite rare to find a MikroTik hardware which has several slots for disk. Okay, there are some. NFS, next point, you can have common repository. You can synchronize it, which is the last option anyway. And it may be used together, the shared network file system and some kind of service which synchronize it. You can have some repository. I can imagine you can use it. To the next point, encryption. Okay, it's up to your paranoia. What encryption is available? You can use either Linux native device mapper crypt, which you can use for any storage device, or you can use Opal disks. So only disks with Opal you can use the native. It's called CED. Disks which comply with this standard, you can use their own encryption, and the CED stands for self-encrypted drive. Okay, and the last, because we already mentioned the very last one, the synchronization, is the iSCSI or NVMe over TCP. So generally, those are services which are or which allow you to send whole block device or part of block device over network somewhere else, and you can use it somewhere else. And that's maybe something we will talk about later. What hardware you can choose? Okay, for client applications where you consume those services, almost anything what has supported architecture, because all those services can be both client and server. So you can have Samba client, you can have Samba server, you can have NFS client, NFS server, iSCSI server, iSCSI client. All of that is supported in both ways, as far as I know. But if you use some, I don't know, encryption or large data transfers, you may need to need some more processing power. That's all. But for server applications, despite of the supported architectures, you need the real storage device which you want to serve over network. And that limits you very much to the hardware that really offers it. And there is a MikroTik on the hardware page of MikroTik. There is a link called Product Matrix. And there you can find all of the boards or devices, what ports they have, how many Wi-Fis they do have, which is not important for us, but it is all there, and you can download it in CSV format, and you can find whatever device is appropriate for you. So what are we searching in this file? We are searching for USB port, SATA port, or NVMe port. Unfortunately, okay, there is micro SD port, which is not mentioned here. It's on some devices as well. But NVMe port and SATA port, it's not mentioned there, so you have to find it elsewhere. And I will tell you some devices which support it. But you can find devices with USB port. Okay, so what is the result of such a package? It's a nice idea. It's generally not much in focus because it's in root.rs for 1 year, and it's purely documented, but it seems to have a lot of potential. But if you look at the hardware you can choose from, you see that MikroTik is really not the vendor that is focused on storage, of course, because it's router. Okay, so what can be the real-world application of such a package? Why somebody has been even thinking about using or adding this package to root.rs? Okay, maybe some guys from MikroTik wanted to have their own storage servers using their own operating system, I don't know, but what is good for us? How can we use it? So let's look at the possible use of such a package or such a services. So let's take a premise. We've got a lot of devices. We are managing, I don't know, tens, hundreds, thousands of devices, and a lot of them have some kind of storage device. And they run anyway. They run all day through, because they're network devices, we need them to be running 24/7. And another benefit may be consumption, because consumption of some added storage is not much more than the device consumes itself. So let's assume that the consumption is close to negligible. So how can we make advantage of it, or take advantage of it? Okay, so here's the vision. The vision is, okay, it's a picture which is or which was produced by artificial intelligence, so it's some kind of surrealistic vision of the probably apocalypse, but okay, it should depict a lot of network devices with a lot of storage devices connected to them, creating one big network. And let me think. Well, hasn't been some kind of buzzword some years ago, something like hyperconvergence, when we were talking about virtualization? We had virtualized servers, and we had storage servers, and somebody thought, okay, why not to put it together? So here's another vision. We can put storage to the network devices itself because they run anyway. It's quite natural that they're online all the time, or almost all the time. So why not to use them? And quite nice benefit can be that the geo-distribution is like a natural feature of it. Okay, so what can be the pros and cons? What is the bright and dark side of it? So pro, okay, the geo backup is one of the probably advantages which I already mentioned. You need no additional hardware because you use already deployed hardware which is there sitting at its place anyway, and the hardware is located maybe on the customer premises, so they doesn't care whether 1 or 2 watts its consumption is less or more, because it has to run there anyway. And if you change the type, the consumption can change even more dramatically than adding one USB storage. So what can be disadvantages on the other side? It can be worse availability, reliability, and serviceability, if I pronounce it correctly. And of course, MikroTik hardware, as I said even before, is not built for hosting storage generally. We have some devices which can host some kind of storage. We will look at it at least a little bit closer later, but generally those are routers, so it's natural that it's not built for it at first place. Okay, and speed. Speed is, of course, limited by the network, so it should be deployed, or you should be thinking of deploying it over fast networks. But the networks nowadays, as far as I can see, are somehow over designed because people generally don't use that much storage as is being sold to them. But the network will be a limitation because in data center, of course, you can have 10 gigabit connection or even faster between servers and some storage, even if it's over network. And that will be not the case when you want to use some remote storage. And speed is one thing, and latency, which is not mentioned here, may be accompanied, and it may be a problem as well. Okay, what else we should think of when we are thinking of deploying such a vision? Okay, whether to serve the storage to the clients directly, or whether to serve the storage to the client through some proxy or controller or whatever we call it. And if we want a controller, where to locate it? On another router's device, in a virtual machine, in a Docker, which can be in a router itself. Okay, where to put the encryption and how to service it, because you don't want to, I don't know, climb some mast just because some disk has failed or whatever. It should be somehow reasonably designed. So what can be the adaptation of those thoughts to the real world? So due to speed and network, I think it's quite natural that we are talking only about cold storage. If for those who don't know what is cold storage, is storage that is not accessed often. It may be quite bigger, and it doesn't need to be that fast. Okay, we need to think about number of replicas or copies, or however we call it. For example, Ceph as a hyper-converged file system or storage system uses 3 replicas by default. And it's for data centers, so we may be thinking about even much more when we try to put this into practice. And last but not least, we need to find some hardware. And of course, hardware, as I already told you, is quite hard because the matrix, which I was pointing at, is not mentioning NVMe slots, and it's not mentioning SATA slots. So here's an example that Dude Edition RB1100 X4 has got 4 SATA slots altogether, and for example CCR 2116 has got 1 NVMe slot. That's just an example. For example, the higher model doesn't have, or at least the M2 slots which are advertised to be there are advertised as SATA slots. Okay, and there is the middle line which I skipped, and it's plenty of devices which have got some kind of USB connection. Okay, and don't think about RBM33 because it's unsupported architecture. So, what are the disadvantages from the start? We cannot think that we can do everything what we are used to from full-featured operating system. It will be always some kind narrow to the operation which is crucial. So it will probably be never full features. Monitoring may be a problem. Okay, we try to put NVMe disk into the CCR 2000, and okay, it has got monitoring of the spare, so you can see the wear out of the disk, but I do not know personally right now how to collect it via standard SNMP. I can collect it via another means, but it's just another step which is a little complicating things. Okay, there is no native bandwidth management. And if you want to deploy the USB or other kinds of storages somewhere in the wild, you want to limit their speeds, not to limit other connections. You want to use for it some extra bandwidth. Okay, so it doesn't have native speed management, but okay, it's in router, so you can use plenty of ways how to manage speed in router OS. Okay, there are some features missing, like authentication, for example, for iSCSI, and there are still things that are, let's say, work in progress, really, like me, myself, I found at least 2 things which I will need to report to MikroTik to repair. And the last version which I really tested somehow is version 7.14. I haven't tested the beta 7.15. Okay, so what we did a proof of concept. Proof of concept. We put all together 3 devices. Well, then we added the CCR just to play with the NVMe disk, and we put it in a lab to see how it behaves. So I wrote or draw my friend a diagram. And here is the wiring. You can see that we used 3 RB5009s, and there I used micro SD card in the USB reader, because those devices has got USB 3. In fact, they behave like 3.2, which is not advertised, but it's reported by system, and we put it together to create some kind of simulation of the or how the very basic network setup can look like. It can be layer 2, it can be layer 3, doesn't matter now. We will talk about that later, but the basic is 3 devices, 3 storage devices, and let's put it together. So we succeeded in attaching iSCSI storage. We succeeded in attaching NVMe over TCP. Well, we can use it even with USB, but it's kind of, let's say, nasty hacking of the protocol for the purpose it was not built for, but you can do it. And you can use RAID, and you can use Ceph OSDs. Do you know what is Ceph OSD? No. So Ceph is, let's say, storage system distributed for hyper-converged virtualization or storage. Of course, it's probably mostly used for virtualization, but the storage is the main thing. And OSD is the basic unit there. It's kind of disk. If you have a server, I mean a real server, or 3 servers, and you have 1 disk in each of them, 1 disk is 1 OSD, another is another OSD, another is another OSD. So together, it's 3-way mirror by default. As I mentioned earlier, Ceph uses 3 replicas by default, so it's mirror of 3 disks, split across 3 servers. Of course, 1 server can look at it through or directly or through proxy, and we'll see 1 big storage created, but that storage is internally made of minimum of 2, by default 3, but you can multiply it or you can add more disk as you like, as you want to be more resilient to outages or whatever. And for you, it will look like 1 storage. So unfortunately, Ceph doesn't like imported disks over network, because it's a system which uses native disks which are present in the system itself, where this daemon resides. So it was not that happy with the really raw device, but we managed to add it via so-called Blue Store type of OSD, which is some kind of hack how to add any kind of block device into the system. So that's what we tested, and we found out it's basically working. So we can split it split the disk or add more disk to the network and create bigger storage. And the basic functionality is okay. So what can be done better? You can use tunnels for better connectivity to the controller or to the client, but the tunnels will add extra headers, which is not wanted. So maybe it can be better to use anycast addresses in rooted networks to be able to freely move the disks or the failed disk to replace by another, just simulating its address is somewhere else with new storage. Or even the controller, if controller fails, you can spawn it somewhere else, and using anycast, it will look like nothing has happened. So Ceph or something like Ceph should be the way to go, because you want its features, you want its self-healing features, you want its scrub features. Ceph was built for resiliency across a very big number of servers, so it's a nice system which we can try to use, or something similar. And what else? What else you can think of? There is always something. You can use encryption. Well, there is downside of the encryption. The documentation of encryption says something like 3 dots, and that's all. So you can try yourself. But basically, you can, if you send the whole block device to client, the client can do the encryption him or herself, and or itself, and you are free of the CPU power that would be needed to do such encryption. So, and you don't even care what the data is stored, because it's the client data, and you don't want to see it, and it's the problem of the client to encrypt it by themselves. So that's probably all. Thanks for attention. The time is almost over, so if you have some questions, I'm open. No questions?
No, any question?
Yes. Microphone, thank you.
Well, one idea that could be fun to try would be to set Proxmox storage up where you are using ZFS over iSCSI. So you use these 3 disks and you just set it up as a ZFS iSCSI. That could be fun to try.
Yes, you can, basically. I haven't tried myself, but I tried iSCSI server from RouterOS to Proxmox as an iSCSI client, as initiator, and set up the Ceph, which is, and there is even Ceph iSCSI gateway, so you can serve the iSCSI as a target from Ceph itself. But it's similar, and you can use it.
I think I'll go home and try.
On the back.
I would like to ask if there is some SNMP monitoring for this array or similar.
I don't know about SNMP monitoring.
Thanks.
Which doesn't mean there is not, but I didn't find it out.
Yeah, thinking about a possible use case, I'm managing a lot of remote locations, fire station in my case, and I'm running MikroTik router on each location and something clients doing some stuff on the fire station, in my case Raspberry Pi.
Something for what?
Fire stations. Fire stations
Fire?
for firefighters, hasiči.
Fire stations?
Yes.
And what do you want to do for fire stations?
No, what I'm meaning, I have some technology on the fire stations.
Okay.
And the technology is mostly Raspberry Pi 4,
Okay.
now 5.
Okay.
And I'm aware that these Raspberries are capable of netboot. I'm thinking about, do you think is it possible to configure MikroTik as a netboot server?
Yes,
so
it
it
is,
can netboot some devices there?
Yes, it is, but it's another functionality. It's called TFTP server. So you will use DHCP with TFTP. And they are saying it works.
Any other questions? So, thank you for the great presentation.